Hi everyone, I'm sorry that I couldn't be in class today, but what I'm going to do is have this video lesson for you to listen along to and watch so that we can still get some notes in today. If you could, please do two things for me. Look over the homework answer key, which I have posted on rationalizing with square roots. That is going to be under the homework section that you had your homework in last night. And then also read through this, including the first question. So pause the video and do those two things for me. Check the homework and read through this and read the first question, and then we're going to be going into it. Okay, so we have a question here saying that we want to analyze if Bob is correct or not. And so what you read through what the Pythagorean theorem is that a right triangle can exist such that the largest side, when you take its value and you square it, should equal the sum of the other two sides' squares. Okay, or in other words, if we call the largest side C, C squared would equal, if we call the two smaller sides A and B, A squared plus B squared. And so in this question, 40 feet, 42 feet, and 58 feet were given to us as measurements for this right triangle. So if we try substituting them in and we see, does the sum of the two smaller sides squared equal the third side squared, we would be seeing if 40 squared plus 42 squared equals 58 squared. Okay? I'm just putting a little question mark on top of the equal sign because we don't know if this is true at this point just yet. Okay? Now what I'm hoping you did after reading this first question is you might have tried this yourself already. Okay? And what you will find is that 40 squared plus 42 squared does end up equaling 58 squared. So what we would be able to do is show those calculations, okay, without the question mark in the equal sign any longer. So part B said, if so, is Bob's argument correct for why it would be a right triangle? And his argument really isn't that great. Okay, he says that he'll attach two sections of the fence together and swing the two short sides together, and they'll end up meeting up. Well, that's not necessarily the best phrasing of that, because that just describes why we could create a general triangle. Okay, so if you have three sides that might be able to make a triangle, they would swing together and connect. Okay, it's the fact that these two swing together and connect at a right angle that is special here. So is Bob's argument correct? Okay, no. He describes why we have a triangle in general. So what would be a better argument? And that would be the title of today's lesson and the title of this worksheet. Okay, a better argument is the converse of the Pythagorean theorem. So the Pythagorean theorem states that if you have two sides of a right triangle, that you could find the missing third side. In this case, we knew all three side lengths, and we wanted to see if that triangle was a right triangle. So we're working the idea backwards. So if we do through substitutions, three substitutions in for the two shortest sides of a triangle and the third longest side of the triangle, and this ends up being an actual correct equivalence, all right, then the converse of the Pythagorean theorem is true. So those three measurements did end up making a right triangle. So what I have on the other page today for you are some examples of clearly, possibly not drawn to scale right triangles. Okay, so on purpose, some of these do not look like right triangles, but maybe they end up being one. Okay, so in this first example, clearly it doesn't look like there's a right angle in here. So we have to just see, of the three sides, which one the largest side is. That's the one that's going to be called C. All right, this is also known as the hypotenuse, a Greek word, okay, and that means longest side. Whereas we refer to the other two sides as leg A and leg B. So we use a lowercase a and a lowercase b to represent those sides. Those are kind of interchangeable. A lot of times you see the smallest side labeled a, but it really does not matter. The only thing that matters is the c value is the largest one. So we're testing basically to see is if this should have actually looked like a right angle. Okay, is it a right angle? And we can test that out by using the Pythagorean theorem to our advantage. Is the sum of each of the legs squared equal to the third side squared? So we're saying, is 8 squared plus 15 squared equal to 17 squared? Okay, now just to show your work, okay, I know you could type that in the calculator. You should show each step independently when you're showing work for these questions. So we should show 64 plus 225 and ask ourselves, does that equal 289? And after we take the sum, 289 does equal 289. So yes, this ends up working out, okay, and this is a right triangle. Okay, because it was 3 integer values that made this true, this also has a special name, just to let you know what that is. Okay, if we have 3 integer values that can't really be simplified in the fact that they're in the smallest ratio together, so 8 to 15 to 17 is a reduced ratio, okay, this is called a Pythagorean triple. Because it is 3 quote-unquote nice numbers that made this work out. Now, with practice today, you're going to see that on this sheet, I have given you all pretty much nice numbers, okay, meaning whole number values. Okay, but when we go into the homework tonight, I'm also going to be giving you some that have square roots in them. But keep in mind, when you take the square root of something and then you square it, the square root is just basically being undone. So it's not going to be that big of a deal. But now maybe you understand why this is within our square root, little extras that we're taking care of. So here we have another one with 7, 24, and 25 in order from least to greatest. So if 25 is supposed to be our C value for this problem, we're basically testing out that should have been a right angle right here. Okay, because the right angle is across from the largest side when we draw a right triangle. So does A squared plus B squared equal C squared? So does 7 squared plus 24 squared equal 25 squared? Well, we have 49 plus 576 if we square each of those. Of course, your calculator should be used for something like that if you don't know those squares. We're seeing, does that equal 625? So all this time, we aren't sure. I'm putting question marks above those until the final end when I add these two together, and I end up getting that 625 is equal to itself. So this one also is a right triangle, which means that we've just discovered yet another triple. Okay, we have another triple of 7, 24, 25. And this one over here was called an 8, 15, 17 Pythagorean triple. All right, let's look at another one where we have our diagram. Now also to get the point across of things that are not drawn to scale, I made this one look like a right triangle, but we're going to discover even though 8 is the largest side value, and I'd still call that C, in this case, I made it look like a right triangle, and it's not going to be. So we have A squared plus B squared equals C squared, our Pythagorean theorem. We're seeing, does 6 squared plus 7 squared equal 8 squared? Or 36 plus 49, is that equal to 64? And so this is the first time that our question mark equal is going to be replaced with a not equal sign. Since 64 is not equal to 36 plus 49, instead we have 85 equal to 64, which would make no sense at all. Okay, so this is not a right triangle. Okay, which also then means that 6, 7, 8 did not make what we call a Pythagorean triple. Okay, I'm going to say pause the video again for a moment so that you can try some more with the diagrams, okay, and you can try some more with these, all right, and then you can, come back because I'm going to actually jump to the homework for just a second and show you one with a square root just to make sure there's no confusions with that. But the answer key for this has already been posted. So you can take a look at these that you get to try and see how you do. All right, so now just one quick little preview about the homework that I'm giving you tonight. Okay, it's a puzzle, so you should be able to check your answer pretty much before I come back tomorrow and show you the answers for these by doing the puzzle. But let me highlight one question here. I'm going to go to question 6 just to show how this might happen with our square roots. Now, this one says that c is going to equal the square root of 97. All right, if we want to consider what the square root of 97 would be, it's just under the square root of 100, so it's a little less than the value 10, meaning it definitely is bigger than 9, because that would be 9 times 9, or 81, so it's bigger than the square root of 81 as well. So I do know it's the biggest side, but if we ask ourselves, does a squared plus b squared equal c squared? Well, 4 squared plus 9 squared, does that equal the square root of 97 squared? So in this case, you could technically try to do, a little bit written out in square root of 97 times square root of 97. But the thing is, a square root and squaring are opposite mathematical features, kind of like multiplication versus division or addition versus subtraction. So they reduce each other out of the question. So that's just going to become 97. 4 squared, we know, is 16. 9 squared is 81. And even though we didn't know it up to this point, we now add these together and we can see 97 does equal 97. Okay. Please know that you can only cancel out or reduce out a square with a square root, okay, for the values that are inside of a square root or a radical symbol here. Okay, if they had a coefficient in front, that coefficient would still have to be squared, and we're going to take a look at those tomorrow. But I just wanted to preview this one with you, and you can see I give you the workroom inside here in the puzzle space for you to square each of those. And then you really just need to test, 16 and 81, that does make 97. So it does check, yes, it would be, and you can fill out the puzzle down below. Okay, so that was a short little video today. Okay, but don't forget you should have used some of the other time where you paused the video to look over your homework from last night. Do now, as well as try these practice problems. Okay, now these practice problems I have the answer key posted to already, so you are responsible to check your work, please, for those. And then I expect you to turn in your sheet. Even though I don't normally have you turn in your notes, please turn in your note sheet today digitally. Okay, whether that means you're taking a picture of printed notes and then submitting the picture, or just submitting the digital file, I don't care, that's fine. But submit your notes so I know you did stuff while I was gone. This should all be complete, and then you can start your homework at the end. Okay, have a great day.